In this lesson, we will address the question of how are arcs and chords of circles associated with central angles. A few vocabulary words first. A chord is a segment whose endpoints lie on a circle. So for example, notice that the points D and E lie on the circle, so I would consider the line segment DE a chord of the circle. Similarly, the points E and F lie on this circle, so I would consider EF a chord of this circle. Now, a central angle is an angle whose vertex is the center of a circle. So notice that the vertex of this angle DCF, the vertex is at the center of the circle. So I would call angle DCF a central angle because it's in the center of the circle. Hence the name central angle. An inscribed angle is an angle whose vertex lies on a circle and whose sides contain chords of the circle. So for example, an inscribed angle would be angle DEF, since the vertex lies on the circle itself and the sides contain chords of the circle. We already said that DE and EF are chords of the circle. Okay, so a little bit more vocabulary. We need to talk about what an arc is. So an arc is a continuous portion of a circle consisting of 2 points on the circle called the endpoints of the arc and all the points of the circle between them. So if you take a look at this circle C here, I would consider this piece an arc of the circle, okay? Since it's a continuous portion of the circle consisting of 2 points that are on the circle, D and F, called the endpoints of the arc. So I would label this arc in this way, arc DF, since those are the endpoints of this arc. Okay? So a minor arc in particular is an arc whose points are on or in the interior of the central angle. So for example, take a look at this central angle DCF. Notice that all of these points here are on the interior of this angle, or on the inside. All of these points are on the inside of this central angle DCF. Therefore, I call this a minor arc. Contrast that with the definition of a major arc. A major arc is an arc whose points are on or in the exterior of a central angle. So for example, this arc here is called an exterior arc, an exterior arc. Why? Because if you take a look at the central angle DCF, I called all these points, the collection of all these points, the minor arc because they're on the interior of this angle DCF. They're on the inside. However, if I take all these points on the outside, okay, I refer to all these points as a major arc. As a major arc. Okay. A semicircle is an arc whose endpoints are the endpoints of a diameter. So if I have the diameter of a circle, I consider this arc here a diameter, or a semicircle. Sorry, I refer to this arc here as a semicircle. Okay. So on to the measures of arcs. Okay. What we're going to say is we're going to define the measure of this arc here, arc DF, to just be the measure of the central angle DCF. So you should be able to see that as this central angle gets bigger, the measure of this arc is going to get bigger according to our definition, which is a desirable characteristic. We want that. We want the measure of this arc to somehow be tied to the measure of this angle, because the measure of this arc should increase as this angle increases. So for example, if the measure of this angle DCF was, let's say, 90 degrees, then I would say that the measure of arc DF is 90 degrees. Now the measure of a major arc, like arc DEF, is just 360 degrees minus the measure of its central angle. So once again, let's say that this angle DCF here measures 90 degrees. Right? Then since the angles inside of a circle add up to 360 degrees, it only makes sense that this angle here would, or this arc rather, would measure 270 degrees. Because we already defined this arc here to measure 90 degrees, the measure of the central angle DCF. And of course, the measure of a semicircle is 180 degrees, because the central angle measures exactly that much. Okay, we also have something called the arc addition postulate, which pretty much makes sense. You would like to think that the measure of this arc, AB, plus the measure of arc BC is equal to the measure of the arc AC. Or sorry, arc ABC we would call it here. Arc ABC. Okay. So we adopt this as a postulate. We say that the measure of an arc formed by two adjacent arcs, or arcs that are next to each other. Adjacent means next to each other. So the measure of an arc formed by two adjacent arcs, AB and BC, is just the sum of the measures of those two arcs. So for example, if this arc AB measures, say, 30 degrees, and this arc BC measures 20 degrees, then the measure of arc ABC would be 30 plus 20, 50 degrees. Okay, so we addressed the essential question. How are arcs and chords of circles associated with central angles? Well, the measure of an arc is just the measure of its associated central angles. If two chords are congruent, then the central angles associated with them are also congruent. We're going to see this in class. We didn't talk about it during this online notes class, but we're going to do an experiment during class that will show that if two chords are congruent, then the central angles that are associated with them are also congruent.